We've been talking about topographic maps, and sorry, that was my printer. I've also got guys putting a new roof on my house, so if we hear a lot of pounding here in a minute, that's what that is. I apologize in advance. Uh, so we've been talking about topographic maps a little bit, and it's it's time to think a little bit about this concept of watersheds. So watersheds, you can think of the entire world as being divided up, the surface of the world being divided up into a series of interlocking funnels. So if the rain falls uh, on one spot, it'll flow down the side of the funnel and then drop down at the bottom. And you can think of the, the bottom of the funnel as being a stream. Uh, so water is constantly running across the land surface into streams and then heading eventually down into the ocean. And depending on where it falls, which funnel it funnels into, each funnel is a watershed. So one way to think about that, or one way to consider that, is by looking at this topographic map. So this is it's called a watershed or catchment basin, and there's a topographic map here. You can hear the pounding from my guys working on my roof. And this is from Clayton County, Iowa. So I'm going to slide this up a little bit. Hopefully we can see it well. There we go. All right, so what do we have here? We have a lake, and this dashed line is a stream, and there's another stream that comes down and merges. We can tell which direction the stream is flowing by the rule of V's. You can see where the stream crosses contour lines, which are these solid lines. There's a V. I'll just highlight one of these V's here. It looks like that. That V is pointing upstream. So the streams are flowing down like this, and then flowing out. So what we're going to do is we're going to define the location of a watershed, the watershed on this map, from any water that would fall into these two small streams and into the main stream, headed down to this symbol right here that looks kind of like a nuclear hazard symbol. So what you need to do is you can just sort of randomly pick a spot here and put your pencil down on the map and ask yourself, does a drop of rain, if it fell on that spot, let's say right here, is it going to end up flowing into one of these two streams or down into this stream, or is it going to flow the opposite direction and flow away from those streams? So remember that the streams are in the bottom of valleys, right? So if you start at the stream and you start moving away from the stream, you have to be going uphill, right? So here we are at 1,100 feet above sea level, and then we move up a little bit higher. We get to this point, and you notice that this contour line sort of wraps around. So what we're doing is we climb up like this, is we're climbing up to the top of the hill, and then we start going back down the other side to the bottom of this hill where this stream is. If you continue this way, you're going uphill, and then back down the other side. So take a minute before you start trying to figure out where before we move on to how to define the watershed, just by looking at this map and seeing if you can figure out what is actually going on here. It's a little bit complicated, but you can make sense of it. So if you start on this stream over here and you move to the southwest, you've got to be climbing uphill because you're moving away from the bottom of the stream. You get up here to 1,200. You notice that this line right here is 1,200, as is this. These closed contours are just little hills at the very top of the hill. So you're climbing uphill like this, you reach the crest of the hill, and then you start going down the other side towards another valley. Okay, so where would the boundary of the watershed be? So where would water run if it landed right here? Well, it would run perpendicular to the contour lines, and it would run down to the stream, right? So is this point within the watershed for this stream, and this? Yeah, of course it is. So we got to move further out. What if we move up here? Where would the water go? Well, it's a little hard to tell, but it would either go down here like this, or it would go down like this. So it's still, I'm just trying to draw those perpendicular to the flow lines perpendicular to the contour lines. So all of this in here is still in the watershed. So we've got to move further out. What about here? Where would the water go if it landed there? Well, it would flow down into the stream. What about over here, let's say? Where would that go? I'll let you think about that for a second. Where would the water go that lands, a drop of rain that lands right here? Well, you can see these closed contours. This represents the top of the hill. So if we're here, we are on the side of the hill that's going to flow down towards this stream. But if we're over here, we're on the side of the hill that's going to flow the other way. So the watershed boundary, basically the rim of the funnel, has to exist somewhere between here and here. And so we can kind of draw a line that goes like that. And that line represents the lip of the funnel. Where else might it be? Well, I'll give you a minute to keep working around, starting at this line, moving it around, and seeing if you can figure out where the rest of the watershed boundary is. And what you're going to end up with is a closed loop. It doesn't have to be a perfect circle, of course, but it's going to be a closed loop. It's not going to have a line that just stops anywhere. So I'll stop there and I'll come back and then we'll talk about it.